Saying hey from West Virginia. All right. So, clearly not. But I'm going to give you a great joke of the day, and I think you're going to love this. Out in the fields, here we go. What do you call a potato wearing glasses? A spectator. I like that. That's a good one. Okay, well, let's investigate. Let's put our glasses on and investigate the product and quotient rules for nth roots. These are going to be very familiar, or very similar anyways, to your product and quotient rules for square roots. If you recall, the product rule for square roots said if you have two numbers being multiplied underneath the radical, you could go ahead and do the multiplication, then take the square root, or you could take the square root of each one individually and multiply the results of those together. You're going to get the same thing either way. Well, your product rule for nth roots says the same thing. If I've got numbers being multiplied underneath a radical with an nth root to it, I can multiply the numbers together and then take the nth root of that, or I could take the nth root of the first factor, the nth root of the second factor, and get those nth roots, multiply those results together. I'm going to get the same thing either way because of the pan balance idea. That equal signs the fulcrum in the middle. This is in this pan. This is in this pan. It's all balanced out, so that means these two have got to be the same. So it doesn't matter the order that you do these particular operations when it's multiplication. Quotient rule for square roots said if I have a fraction underneath the radical, I can go ahead and do the division, then take the square root, or I could take the square root of the numerator, square root of the denominator, and then do the division. I'm going to get the same result either way. Works for nth roots as well. So the quotient rule for nth roots says I can do the division, then take the nth root of that result, or I can take the nth root of the numerator, nth root of the denominator, and then divide the results of those. I'm going to get the same thing either way, again, because of the pan balance idea. So like I said, very similar to product rules and quotient rules that you already know. We're just dealing with nth roots. So let's take a look at these examples where I'm simplifying. Notice here I went the 4th root of 48. Now what that means is I should have 4 slots. I should have the same number in each of these 4 slots. I should be able to multiply it together to get a 48. Can you think of a number that you can multiply by itself 4 times to create a 48? Nope, because 2 times 2 is 4, times 2 is 8, times 2 is 16, not big enough. 3 times 3 is 9, times 3 is 27, times 3 is 81, too big. So none of those will work, so I'm going to simplify my radical. And remember, simplify means, now when it was square roots and I was simplifying, that meant I didn't want perfect squares or pairs underneath. Pairs because the understood index here is a 2. That's what tells me pairs. So with nth root, this means I don't want perfect quads or sets of 4. And frankly, that's the easiest way to do it, is to look for a set of 4. Now with square roots, when I had a pair and I had the same number here, what happened was I took, let's say a pair of A's here, I took one out and it dissolved, remember, dissolved the other one. So similar idea is going to happen here. If I'm looking for a perfect quad, when I see 4 of the same number, I will take one out, it will dissolve the other 3. So it's similar concepts, but it's all based on this index. So what I'm going to do then with my 48 is I'm going to employ this product rule, and I'm going to say let's split it up into its factors. In other words, let's break down, and try to find sets of 4. Well, I know that 48 is 6 times 8, but that doesn't help because I can't think of a number that I can multiply by itself 4 times to create a 6. I can't think of a number that I can multiply by itself 4 times to create an 8. So I'm going to continue to break it down, looking for those sets of 4. 6 is 2 times 3. 8 is 4 times 2. I still don't have a set of 4, and I can't think of a number that I can multiply by itself 4 times to create a 2, nor 4 times to create a 3, nor 4 times to create a 4. So I'm going to continue to break it down. That 4 right here is 2 times 2. So I have 2 times 3. Here's the 4 with 2 times 2. And here's that 2 in the back. And notice I have a set of 4. So when I have a set of 4, like I said, what happens is I take one out and it dissolves the other 3. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and the 4th root of 16 would be 2, because that's what it took to create the 16, 4 2's. So I'm going to, like I said, take one out, dissolve the others, and that will give me 2 on the outside, 3 underneath, and that is as simple as it will get, because I can't think of a number that I can multiply by itself 4 times to create a 3, and that 3 only breaks up as a 3 and a 1. That doesn't help at all. So this is as simple as it's going to get. Now let's take a look at the next one. 5th root of 8. That means 5 slots. Same number in all 5 slots to create an 8. Well, a 2 times 2 is 4. 4 times 2 is 8. That's only 3 slots. I need 5. So I don't know a number that I can multiply by itself 5 times to create an 8. So I'm going to use my product rule again, but what I'm going to do this time is I'm going to put them together. However, notice, very important that you see that you have the same index. See here, same index. If you do not have the same index, you cannot do this. And similar idea here, I have to have the same index. So since these are both 5th roots, I can put them together and I can say I'm going to call this 5th root of 8 times 8. But again, I'm looking for sets of 5 slots. So I can multiply 8 times 8 to get a 64. Now if I know the 5th root of 64, I'm going to go for it. But I can also just break it down, break it down, break it down, and look for a set of 5, which is what I'm going to do. Now I have to be careful. Because I need to look for those sets of 5. So rather than multiply it as a 64 and then split it up again, I'm just going to go ahead and start breaking that thing down. So I'm going to get 5th root of 8 is 4 times 2 like we said before, and the other 8 is 4 times 2. And now what I'm going to do is I'm going to say I still don't have a set of 5. I can't think of a number that I'm going to multiply by itself 4 times to create a 4. So I'm going to continue to break it down, break it down, break it down. So 4 is 2 times 2. Now here's this 2. This 4 is 2 times 2. And here's this 2. Aha! I have a set of 5. So now when I see that set of 5, I'm going to, like I said before, take one out and it dissolves the other 4. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. It took those 5 2's to create a 32, so therefore the 5th root of 32 is just a 2. So I'm going to take that 2 out, leaving this 2 underneath, and I can't think of a number that I can multiply by itself 5 times to create a 2. I can't break this 2 up into anything useful because it would just be a 2 and a 1. That doesn't help. So this is as simple as it's going to get. Now let's take a look at the last one. Remember, my quotient rule says that I can take that 125 and divide it by 27 and then take the cube root of that, but oh my goodness, that's going to be some terrible decimal. I don't want to do that. Instead, I think what I'd rather do is split this up, take the cube root of that numerator, take the cube root of that denominator. So now I'm looking for a number that I can multiply by itself 3 times to create a 125. Well, 5 times 5 is 25. 25 times 5, yep, 125. So the cube root of 125 is 5. Now, I want a number that I can multiply by itself 3 times to create a 27. Well, 3 times 3 is 9. 9 times 3 is 27. Aha! Cube root of 27 is 3. So see, that's so much easier than trying to do that division and create that decimal and then try to get the cube root of that decimal. That would be a complete nightmare. So this product rule and this quotient rule, super, super helpful for simplifying your radicals that have nth roots. Very similar to what you had done with square roots. You just pay close attention to that index because the index tells you how many of the set you need. If you have a 4, you want a set of 4. If you have a 5, you want a set of 5. If you have a 3, you want a set of 3. And in order to split things up or to put them together, just remember you have to see the same index. I hope that helps. Have a great day.